Okay, so we're going to expand this logarithmic expression. To expand an expression means to take it and rewrite it. So you're going to take one log and rewrite it as the sum or difference of two or more logs. So this one actually doesn't help us that much, but in order to do the reverse, we have to know where it came from. So that's what we're going to do here. So when you expand these, the first step is to split up the division part. So here, when we divide two things inside of a log, we subtract their individual logs. So here we're going to do log base 3 of the numerator, which is 7x squared, minus log base 3 of the denominator, which is y. And this is using the quotient property. I won't make you say the property if you show your steps. So like right here, this would be good enough. You don't actually have to name it, but I'm naming it here because these are the notes. Okay, the next step would be to split any things that are multiplied together. So we're going to use the product property. So what's being multiplied? Well, remember, the coefficient 7 is not attached to the squared. So these are being multiplied together, which means I can split these up by adding their individual logs. So I'm going to add log base 3 of 7 plus log base 3 of x squared. And I still have this part minus log base 3 of y. Okay, so this one's just going to stay. Okay, we're almost done. You can only have one argument inside the log. So here, that squared, we're going to use the power property. Oops, that is not how you spell power. So power property. And take that exponent and multiply it to the front of its log. So this one is going to end up being 2 times log base 3 of x. But this part's still the same. Log base 3 of 7 plus this one. And then this part's still the same, minus log base 3 of y. Right, so as long as there's only one, there's no products or quotients inside the log, you're done. Okay, so usually the steps are the same. First thing, if there's division, split up the division by subtracting them. So we're going to do log, it's base 10, but you don't actually have to write the 10. So 7y cubed goes here, and log of 4x squared goes here. Okay, and then you can actually split up both of the products in one step. So here you're multiplying the 7 and the y, and you're multiplying the 4 and the x. So we're going to split this one up by adding. We're going to split this one up by adding the logs. So for the first one, it's log of 7 plus log base 10 of y cubed. That's where you have to be careful. So we know this one's going to split up into log 4 and log of x squared. But since you're subtracting these, there's actually parentheses around them, because both of these are being subtracted. Okay, so what we end up doing actually is distributing this and making them both negatives. But let's do the power first. Let's look at the power property. So here, this cube is going to come in front of its log, and this squared is going to come in front of its log. So this part is going to be log 7 plus, because they were multiplied, 3 times log base 10 of y. And then we're going to distribute this negative and make this one a minus log base 10 of 4. And distribute it here and make it minus 2 times log of x. So in the end, any positive exponent, so like right here, the log 7 was positive and the log log 3 of x was positive because they were both in the numerator. Here, the 7 is in the numerator and the y is in the numerator, so those are positive. If they're negatives, negative, negative, that means they were originally in the denominator. So a negative here is denominator, 4 and x squared were in the denominator, so that's why both of them are negatives. Okay, so again, that really doesn't help us much, with the exception of being able to go backwards. That's really the only point of being able to expand, is so that when you have to go backwards, you know where they came from. Because we're going to have to go in reverse order when we condense. Okay, so looking at the bottom ones, when we condense this log, it's going to help us solve for x. So condensing a logarithmic expression is the opposite of expanding. And when we condense it, we write it as a single logarithmic expression. So we're going to take all of this and we're going to combine it into one, and then we'll be able to solve it. So right here, last time we saw that if the bases were the same, we could cancel them out and set arguments equal. You can only do that if it's a single log on each side. Here, you can't cancel out all these logs. You have to condense the left side, and then you can cancel it out with this one over here. Okay, so when we condense, we take expanding and go backwards. So the first thing we're going to do is use the quotient property to see if there's any exponents. So exponents mean there's a number in front of the log. So this coefficient right here is going to move and become an exponent to this number. So it's going to move and become a 3 there. So the log 2, I'm going to go ahead and write the base this time. Log base 10 of 2 plus, when I move it, I get log base 10 of 3 cubed. 3 times 3 times 3 is 27. And then we do minus log base 10 of 9 equals log base 10 of x. Okay, so now you just combine left to right. So whatever comes first, you group these two together, and we're going to combine, come on, give me this thing. We're going to combine these two, because they come first. So since we're adding the two logs, the product rule says to multiply their arguments together. So what do I get when I multiply 2 times 27? I get 54. So here this one's going to be log base 10 of 54 minus log base 10 of 9 equals log base 10 of x. Still cannot cancel them out because we still have multiple logs over here. So the last step would be to combine these two numbers. Since we're subtracting, we're going to divide using the, oh sorry, this was the quotient one. This first one was actually the power rule. So here when we divide, 54 divided by 9 is 6. So we're going to get log base 10 of 6 equals log base 10 of x. So now, since they're the same, we can cancel them out and say x is 6. But you can only do that when you have a single log on both sides. You cannot cancel out before that. Okay, so this is the whole point of being able to expand it so that we can go backwards and condense it to solve. Alright, so these B, C, and D are basically the same thing. So B, we're going to do the same thing as solve for x. C and D, we're just going to condense it into a single expression. We're not actually going to solve because these have variables in them. Okay, so first, we look for any powers. That would mean there's a coefficient in front. So again, the middle logarithm has a coefficient. So we're going to take it and we're going to move it and make it an exponent. So we have log base 5 of 3 plus, when I move it, I'm going to get log base 5 of 4 cubed. 4 times 4 times 4 is going to be 64. And then I subtract log 6, log base 5 of 6, and equals log base 5 of x. Okay, so now you go left to right. So if we group the first two together, since we're adding, we're going to use the product rule and multiply these two numbers together. So 3 times 64 is 192. So again, this is the argument number inside the log. So log base 5 of 192 minus log base 5 of 6 equals log base 5 of x. So then the last step is to use the quotient. Again, you don't have to write the rules if you just show me what you're doing. So here I am going to divide these two numbers. So 192 divided by 6 is 32. So log base 5 of 32 equals log base 5 of x. So now that I got a single log on each side, I can cancel out the bases and say x is 32. Okay, so these last ones here, we're just going to condense them. There's not going to be any solving. So first we use the power rule. But before I do that, looking at C here, this divided by 2. This is not a quotient rule because it's not two logs being divided. In order for you to use the quotient rule, it would have to be ln of x over ln of 2. Or sorry, not that. Ln of x divided by 2. Then you could split it up into log of x, log of 2. This one doesn't have a log in it. So technically we can rewrite this one as 1/2 natural log of x minus 3 natural log of y minus natural log of z. So now that 1/2 is a coefficient, and we use the power rule to take it and make it an exponent. So we're going to take that one and make it an exponent, and take this one and make it an exponent. So we get natural log of x to the 1/2 power minus natural log of y cubed when we move that exponent minus natural log of z. Okay, so from here, I'm going to kind of combine both of these steps. So I'm going to get natural log. We saw that positive logs stay in the numerator. Negative logs go to the denominator. So here, using the product rule, this one is going to stay in the numerator since it's a positive log. If it was negative, it had negative in front. And then both of these, y cubed and z, are going to go in the denominator because they're both negatives. Negative, negative means that y cubed and z are on the bottom. We don't leave a fraction in a fraction. That's why I didn't do it in this order. We would have to combine them together. In the end, don't leave this as a fraction exponent. Remember what fraction exponents mean. 1/2 exponent means the square root of that number. So square root of x over y squared. Oops, that's not a square, that's a cube. Y cubed z. So positive exponents, positive logs stay in the numerator, negative logs go to the denominator. So here I'm going to do the same thing. First, use the power rule to move in the exponents. So the 3 is going to become an exponent here, and the 4 is going to become an exponent here. So log base 2 of a cubed, the first one, plus log base 2 of b, plus log base 2 of, when we move that to the c, we get c to the 4th. So now I'm going to kind of combine these two properties. So this one is a positive log, so it's going to stay in the numerator. This one's a positive log, so positive here, positive, positive. That means all three of these together are going to be multiplied in the numerator. Since there's no subtracting, there's no dividing. So there's actually going to be nothing in the denominator. So we don't need a fraction this time. We just say a cubed times b times c to the 4th. If there was a -1, then we would have divided by whatever the subtracting log was. Okay, so this is condensing. This one, these two really don't give us an answer. This is where we get the answer. And we need it for these expressions. So these say evaluate with adult calculator. So right now, 4 to what exponent is 48? Well, squared is 36, squared is 16, cubed is 64. So it's somewhere between 16 and 64, but I don't know where. So I can't just figure it out like this. So I have to condense it in order for me to figure it out. So again, using the quotient, I'm going to take this coefficient and make it an exponent here. So 9 to the 1/2. So we get log base 4 of 48 minus log base 4 of 9 to the 1/2. 1/2 exponent means the square root of 9. So what is the square root of 9? So this stays 48. This is log base 4 of 3. So now, since we're subtracting these two values, we can combine these two together by dividing the arguments. So what's 48 divided by 3? Well, that's 16. So log base 4 of 16. Now we want to know what is this equal to. So technically, if we wanted to, we can make all of these equal to x and solve. So now we say 4 to what power is 16? Well, we know that 4 squared is 16. so it has to be 2. So this thing is equal to 2. We really don't need the x equals, but in order for you to rewrite it, you have to have something on the other side. So we can change it to an equation. Okay, so for this one, we're actually going to, right here, log base 5 of 15, 5 to what exponent is 15? We don't know that one. If I was to do the same thing I did over here and move it to become an exponent, that would mean I would take the square root of 15. Don't know what the square root of 15 is either. So this time I don't want to move it and make it an exponent. Notice both of these have 1/2. So I'm actually gonna factor this out and say 1/2 times log base 5 of 15 minus log base 5 of 75. So I'm going to undistribute the 1/2 since they both have it. So now I can combine the parenthesis part and whatever answer I get, multiply it by 1/2. So here, since I'm subtracting, I'm going to divide these two. So log base 5 of 15 divided by 75. So I can reduce this. I can divide both of them by 15 and get log base 5 of 1/5. But I still have that 1/2 in front of both. Now solving this part, 5 to what exponent is going to be 1/5. So in order for us to flip it around, we know it has to be a negative number. So -1 is going to keep it 5. So -1 times 1/2 is going to give us that this answer is equal to -1/2. Okay, so using the properties of logs in a slightly different way, but we can still evaluate it without using a calculator at the end. Okay, so the last things we're going to do is solve using these properties. With solving, it is going to be important that you check for extraneous solutions. So sometimes you'll get more than one answer, or you'll get one answer, but it's important you check that answer to make sure it makes the log correct, because remember, you cannot have negatives inside the logarithm. So I'm going to put that right here. When it says check for extraneous solutions, you need to make sure that the answer that you get is not, so no negatives or 0 inside the log, because the domain of a log is positive numbers, so you cannot have an argument that's negative. So if you get an answer and it makes it negative, you got to throw it out. Okay, so here we cannot eliminate because there's not even a log on this side, so we can't eliminate the logs. We can't convert it just yet, or exponentiate just yet, because we have multiple logs. So the first thing we want to do is combine the two arguments together. Since we're adding, we're going to combine them by multiplying these two things. So 5x times x minus 1. So we'll multiply those in just a second. Here, the base of both of these logs is 10, and we're going to make it equal to 2. Okay, so from here, I really don't care if you exponentiate or you take the log, or sorry, rewrite in an exponential form. It's going to give you the same answer. So since we just learned exponentiating, I'm going to go ahead and do that here, but it really doesn't matter. So exponentiating means you write both of these as exponents. So 10 is your base here. Now this is an exponent. And 10 is your base here. So now this is an exponent. So this base 10 cancels out with the log 10. I'm going to go ahead and distribute this. And we're left with 5x squared minus 5x equals, this is 10 squared, and 10 squared is 100. So again, you would get the exact same answer if you were to rewrite it. So if I didn't have this part, I'll do it this time, but I'm not going to do it for the other ones. Without exponentiating, you would say 10, that's your base, squared equals, the argument is 5x times x minus 1, which is essentially the same thing we got here, we just switched them around. So I don't care. This is converting from form to form. This is exponentiating, whichever one you want to do. I know in pre-cal, they do this right here. They use the property and not the definition. Okay, so before we start solving here, notice we have a quadratic. So we cannot solve by getting x by itself, because we can't get x by itself. We have a squared and a linear. So we got to think about how do we solve quadratics. So over here, just remembering how to solve quadratics, we can use the quadratic formula. We can complete the square. We can graph it and find the x-intercepts, or we can factor it. So factoring is always the easier one to check, but if you want to try these other ones, you can try those as well. Graphing, maybe not so much because you're not allowed a calculator, but these other ones you can do if you wanted to. But factoring, remember, the options are GCF, basic, difference of squares, or AC. So right now, for any of these for factoring, we gotta make it equal to 0. So I'm gonna make this side equal to 0 to keep the x squared positive by subtracting the 10 to the other, or the 100 to the other side. So it's gonna end up being 5x squared minus 5x. When I move the 100, it's gonna be minus 100. Now, as is right here, you would have to use the AC because we have a number in front. But if you notice, we can divide everything by 5 first. So we can take the GCF out first. And that's going to help us. So 5x squared divided by 5 is just x squared. Negative 5 divided by 5 is negative x. And negative 100 divided by 5 is negative 20. And 0 divided by 5 is still 0. That's why we can do this. So now, this is just a basic problem. So what are the factors of 20 that are going to give me negative 1? So 20 is 1 and 20, 2 and 10, 3, no, 4 and 5. I know the bigger ones have to be negative. So to give me negative 1, I want x plus 4 and x minus 5. So when I solve, remember you use the zero product property, you set each value equal to 0. If I add 5 here, I get x is positive 5. If I subtract 4 here, I get x is negative 4. So these are the possible solutions, but I have to check them. So when I plug in 5 times 5 is 25, which is okay. And I plug in 5 here, 5 minus 1 is 4, and that's okay. So if I was to combine them and check, we would be fine there. So this one's good. If I plug in negative 4 though, we get log 5 times negative 4 is negative 20. And if you try to do this in the calculator, it's going to say error, not real solution. So because we get a negative inside the log, we throw this one out, and this is your only answer. Okay, so you need to make sure you check for the extraneous one. Sometimes both of them would work, so you got to check both. Sometimes neither of them would work, so then you say no solution. So be careful with those type of problems. Okay, number 6 is basically the same thing. So one more multiplying problem, and we'll do a dividing problem, and then that'll be it. So right here, again, the first thing we want to do is combine this into one log by multiplying. Since we're adding, we're going to multiply these two values, so multiply them. So we're going to do x times 2x minus 6 and make that equal to 2. Okay, so this time, since our base is 6, we're going to exponentiate with base 6. So we're going to do 6 to all this stuff and 6 squared on this side. So these cancel out, but I'm going to go ahead and distribute. So 2x squared minus 6x equals, when I square this side, 6 squared is 36. So I know I'm going to have to get this to the other side because I have a quadratic here, and I'm going to have to divide everything to reduce it. But let's go ahead and move it over first. So when I move the 36 to this side, it becomes negative 36, 0. And then I can divide everything by 2. So I end up with x squared minus 3x minus 12 equals 0. Not 12, sorry. But we're dividing it by 3. Divided by 2 is 18. So negative 18. Okay, so now we can just use basic to say what are the factors of negative 18 that are going to give me negative 3. So 18 is 1 and 18, 2 and 9, 3 and 6. To be negative, the bigger one's got to be negative. So which one's going to be negative 3? X plus 3 and x minus 6. So if I set each factor equal to 0, subtracting 3 on this side gives me negative 3. Adding 6 to this side gives me positive 6. So again, these are the possible ones, but I have to check them. So if I plug in the negative 3 here, 2 times negative 3 minus 6. Negative 2, or 2 times negative 3 is negative 6, and I get negative 12. So log base 6 of negative 12 I cannot have, because the inside number can't be negative. So I throw this one out. If I plug in positive 6, 2 times 6 is 12, and then minus 6 is positive 6, so this one's okay. Log base 6 of 6 is okay. But I gotta check this one as well. If I plug it in here, well, that's just x, so that's just gonna be log base 6 of 6, which is okay as well. So I have 2 of them, so the whole answer ends up checking out. So this is the only answer. The negative 3 gets thrown out. You don't actually have to show the work for checking, but make sure you do check to make sure that you don't get negatives inside the log. Alright, and then the last. Okay, so for this one, This time it's a minus problem. So in order for me to condense this into one logarithm, I have to divide these two. So I'm going to divide numerator divided by denominator. So this argument is going to stay in the numerator, 2x plus 2, and this one goes to the denominator, x minus 2. You don't split these up. You cannot distribute the log and split subtraction or addition up. They stay together. So here, now that I have one log, I can exponentiate, and I want to use base 4 to cancel out this 4. So base 4 here, and base 4 there. Whatever you do to one side, you have to do to the other. So this is going to cancel, and I'm left with this argument, 2x plus 2 over x minus 2. And I can figure this number out. 4 to the first power is just 4. But I'm going to write it as 4 over 1. Because in order for me to solve this, I have to do cross multiplying, multiply by opposite denominators. So I'm going to take 1 and I'm going to multiply it by this side, which is technically multiplying both of these by 1. But 1 times this stuff is just going to be this side. So this side's not going to change. But on the other side, I take this denominator and I multiply it by this side. So it's like I'm taking this and I'm multiplying x minus 2 by the top and the bottom. Okay, so I'm going to get 4 times x minus 2. I don't know why I put plus 2's there. Those should both be minus signs. So again, when you use cross products, you're technically multiplying by opposite denominators, and then you have the same denominator, so you set numerators equal. So here I distribute and I get 2x plus 2. Here I distribute and get 4x minus 8. And now I just solve for x. So get the x's to one side, subtract 2x, and I get 2x over here. And add 8 and get 10. So when I divide both sides by 2, x is 5. So again, that's a possible answer. You still have to check to make sure you don't get negatives, otherwise there's no solution. So here, plugging in the 5, 2 times 5 plus 2. 2 times 5 is 10, plus 2 is 12, so that's positive, that's good. When I plug it in here, 5 minus 2 is 3, so that's positive. I mean, you can finish checking the whole answer, but if you did the work correctly, as long as they're positive, then this is good. But you need to make sure you check for that part. Okay, so those are the main ones. The bottom ones, I'm not gonna have you do any of those right now. Those will be like extra credit ones later. But for now, as long as you can do those, you should be fine.